Hello students, welcome back to online classes. So in the earlier board syllabus classes, we have already discussed regarding ray optics as well as numericals. So now, as we finish that, once the college starts once again, we can go for again revision from that particular ray optics concept. Suppose any doubts regarding the topic is there, means we can clarify later. So as we already completed that chapter number 9, we have to move on to the next chapter from the volume 2 book, that is chapter 10, second PU chapter 10, wave optics. So already ray optics, that means already we have discussed about light behavior when it enters from one medium to another medium. So which and all medium means, yes, we know mediums are being classified into different forms like lenses as well as mirrors, spherical refracting surface and many more. And there are characteristic derivations and so many things we have discussed there. So one thing you have to think of in the previous chapter, ray optics, what we have assumed is light travels in a straight line, like a ray, straight line, right? That is what we have assumed there, and we know all the topics which we have discussed there as well as the diagrams, ray diagrams or the derivations. We have taken everything in a straight line, and that is why in geometric optics we say, correct? So everything is been discussed in that way. But once the science again started evolving, in the sense when science started advancing much and much, okay, soon after the ray optics, discovery of and invention of different optical instruments, all those, okay, like that. So once scientists started discussing or like studying much deeper in the concept of light, some of the scientists comes across, okay, some of the their explanation regarding light. So right now I have listed out in which year or in which particular era, okay, how the advancement in this concept of light is being modified or being developed. So individually writing, instead of that I have written all together along with the scientist's name so that I can explain you all together. Okay, so let us see one by one. Okay, so right now, so we are having the list here, you can see. First one, let us see. Wave I have already written in the, as per the chapter name itself, we can make out wave optics. That means it's about light. Means wave means what? Yes, of course, waves concept you have learnt already. There are two types. One is transverse wave as well as longitudinal waves. And while taking the example of transverse wave, we have come across what is that? Yes, we know light also a transverse wave, correct? So that recent discoveries concept is studied in first PU, but we didn't discuss anything regarding light over there. But in second PU, we will be learning about light. Am I right? That is why we can see here introduction. That means wave optics in the field of light, how the scientists started explaining about the nature of light. Let us see one by one. Okay, so you can see here initially in 1637. So in 1637, one of the scientists, his name is Descartes, and his name is Descartes, Descartes, and he studied about light, and he has started giving the explanation, okay, regarding the behavior of light. Light means what? Because however, when our light falls on any object, because of the reflection, it is being received by our eyes, and our brain processes the information, and we can understand, okay, that object is of that color and that object is of this much size. And when we go near that and touch physically also, we can observe that. By touching we can sense that, correct? Sensory organs, like that. And visually also we can feel that. So like that. So what is light? Whether it's just a straight line, something which is passing in a given medium? Of course it is not. So scientists seriously they started discussing, in a sense they started doing what? Research, all those things regarding this. So they slowly started giving their own explanations. Let us see. In 1637, Descartes, one of the scientists, he has given what is light. His explanation was like this: corpuscular model of light he has given. That means light consists of some minute particles. Okay, some minute particles light contains, and its name is corpuscles he has given. So Descartes, in the year of 1637, he started studying about all this, okay, like behavior of light, all those things. And apart from ray optics concept, they studied and they came to know. So one of the scientists, okay, his name is Descartes, he gave up. That means he came up with one of the concepts, that is corpuscular theory of light, or wave theory of light. So corpuscular wave theory of light. So what he actually explained in corpuscular model of light is, light consists of minute particles. That means it contains some minute particle, and they are called corpuscles. Okay, corpuscles. You can see here. And so 1637, the era of whom? It was Newton's, correct? So of course, in all the fields in science, suppose you check means whosoever scientist comes and give some of the theories, automatically Newton also will be there along with them, correct? So that is why here also Newton will arrive. So in 1637, Descartes has given corpuscular theory, that means model of light, and he told light is actually consisting of some particles, tiny particles, and they are called corpuscles. So Newton came. So what he will do is, of course, he studied Descartes' concepts regarding corpuscular theory of light, and Newton has given a statement. What statement? Wave, that means light travels faster in denser medium and slower in rarer medium. The final output of this theory was light travels with all the medium, right? In rarer medium, slower compared to denser medium. So light travels with higher speed or velocity is okay, no problem. Speed will keep, okay. With higher speed in denser medium comparative to rarer medium was the explanation given by corpuscular theory, that is Descartes followed by Newton. So what happens here? Denser medium, speed in denser medium is greater than rarer medium. So then what happens? There will be international committee, right, where scientists will meet and they will give their theories. In that one, their corpuscular theory was failed. Even Newton also failed. Why? Because there was one scientist. Okay, once this light consist of minute particles was fine, thereafter speed of light in denser medium compared to rarer medium, okay, all these things were explained, right? So later on, one of the scientists, his name is Foucault, okay, so you can write his name. His name was this particular scientist. What he has done is he experimentally proved that light travels faster in rarer medium compared to denser medium. So by that what happens? The theory of corpuscular theory model of light was rejected, or it was a failure in 1637. But whether this Foucault was able to explain the behavior, no. He just showed experimentally that no, Newton was wrong. He was wrong. Light doesn't travels faster in denser medium. It travels faster in rarer medium. That was accepted experimentally. So by that, their theory was slightly a flop show, we can say, whatsoever. Later on, in the same 16th, that particular, okay. So what happens? 1678, after a few years, Huygens principle it was. Huygens wave theory of light, it starts. So according to Christian Huygens, his full name was. So according to Huygens in 1678, okay, according to light travels in hypothetical medium, he has explained. That means they thought that the entire atmosphere is something like covered with ether and light travels in that very faster. That was the concept behind that one. So according to Huygens, light travels in a hypothetical medium. that hypothetical medium, they termed it as ether. So that is what the conclusion given by Huygens in 1678. Like that, after that, what happens? So many, research, all things will take place until where you can see here, 1855. Okay, when 1855, the time has come. Maxwell, Maxwell, one of the most famous scientists. So he has given electromagnetic theory of light. So in electromagnetic theory of light, what is that? So light consists of both electric field as well as magnetic field, perpendicular to each other. That is what explained by that. Okay. So in 1855, it was finally, what is that? Maxwell electromagnetic theory was explained. And so on. And after that, modern physics, in the sense modern science will emerge. So in modern science, what they are going to explain? See, for example, in 1920, Einstein has given the theory of what? Relativity. That in 1920 he has awarded with Nobel. So for what? Photoelectric effects. Am I right? So photoelectric effect, the concept was actually based on the wave theory. In that one, Max Planck concept was even much more studied and is being explained by Einstein regarding the quantum theory of light. In quantum theory of light, what is that? In SLC you might have studied. So in your lower class, what is that? Light consists of tiny packets of energy called what? Quanta, correct? So it has got its own energy and tiny particles are there. What are those tiny particles? Those are actually the photons. So photons actually the tiny particles which are there in light, and rest mass of photon is actually zero. When it starts traveling, yes, we know it gains mass. So this was the entire history behind the, light. Light is not just a ray which is actually a straight line. Light has got this much of explanation in different years, 16th to 18th, different centuries. The scientist has been working for that, and finally they started giving their own explanations. Some of the explanations were taken, that means went wrong. And finally, modern science, we can see here Max Planck's theory and Einstein's photoelectric effect. So where dual nature of radiation, that means dual nature of light, it is being explained, where they explain that light consists of tiny packets of energy called photons. And speed of light also. And one more thing, speed of light is actually discovered by Newton. So in the sense, so they will be doing, that is why denser medium is greater than rarer medium, it is being explained, right? So because of the some of the experiment setup and explanation, in the sense, theories, formula oriented one, that is what they went wrong. But finally, Foucault experimentally, explained. Yes, in denser medium it is less, rarer medium it is faster. So like that, it was the era of experimentations. Then here it was something like hypothesis, hypothetical medium, because it was imaginary, right? So thereafter comes electromagnetic theory, it was successful. And remember, Maxwell's electromagnetic theory is there. No, soon after that, Hertz experiment was established. In a sense, Heinrich Hertz, he was successful in generating electromagnetic wave in lab itself. For example, radio waves. He successfully generated radio waves in lab. Later on, radio waves, thereafter, radio, the instrument by Marconi, like that. So these are actually the slow, development in the field of science regarding the light. After light, what happens? Slowly electromagnetic wave concept comes. Then different types of electromagnetic waves also they started finding out, correct? X-rays also electromagnetic wave, gamma ray, infrared ray, ultraviolet ray. So all these are actually the advancement of science. The basic was started from here, 1637. Slowly they started, Yes. So these are the introduction part of this particular chapter. Hope it was informative for you regarding what? Regarding the earlier discoveries and earlier advancement in the field of optics, that means light, in explaining that. So now let us move on to the next topic, that is regarding the wave optics. Introduction part is fine. Hope you understood this. So according to Huygens wave theory, we will be starting with Huygens concept, okay. Then we'll move on to, when we come across photoelectric effect, the chapter will be dual nature of radiation and matter, okay. We will shift like that. Next chapter, okay. Before that, Huygens theory we will be studying. Corpuscular theory we are not studying here. So here, most of the concept we will be discussing, dealing with the Huygens wave theory itself, okay. Yes. So, using the concept of Huygens wave theory, wave means, of course, you know, wave means there will be, that means transverse wave. How will be the pattern of the wave? This will be the pattern of the wave. Here, crust, trough, like that. So, higher amplitude, lower amplitude, higher, lower, like that it goes. Am I right? So, next, what is that? Wave interference also, you constructive interference, destructive interference. Correct. That means in the previous waves concept, we know what happens when superposition takes place between two waves, and derivation also you have discussed, right? So now, imagine two waves are there. Okay. So two waves are traveling in space in one direction. Like this. So when you compare these two waves, imagine one wave is like this. First, second, third. So there is a small difference between them. What is that? This particular wave, these two are having the same characteristics, correct? Trough, crust, trough. But here, trough, crust. That means, if there are three waves which are traveling together in particular direction, the same direction, when you compare this, no, like this. I start drawing the dotted line like this. Okay, so at this position, you can see both are having higher amplitude, and this one is actually having the least amplitude. That means these two waves are there. No, it has called one particular, what is that term? It is called phase. So these are actually in phase, correct? Phase difference, path difference, we have studied in waves theory. That means waves concept. So in this theory of, what is that, a wave, what we can say? These two are actually having the same characteristic. They are in same phase, but this is actually it's actually out of phase, correct? But here also same phase, both the wave out of phase. So it is actually collectively, we are just checking the phase difference between the waves here. Okay, at this particular point, as well as here. By taking the concept of this, Huygens explains regarding the wave front. Okay, so concept called wave front. So what is wave front? So earlier it was discussed as consists of tiny particles, corpuscles, the electron, it is a wave theory, it consists of particles. Like that it is been explained during the Huygens period. Okay. So right now you can see here, imagine a particle is there. Here particle both are at higher amplitude, whereas this particular one is at the out of phase condition. That means it is actually not having the, what is that, same phase. So phase angle difference is there. So right now, imagine that a ray of light is traveling like this. So, you can see here dotted line I am doing. A right ray is spreading all the direction, only few part I have taken, like this it is going. Okay, so wave front means, okay, line joining the particles which are having the same phase. See, this and this particular wave, the particles are at this particular position now, and the line joins them all together, and their phase is one and the same. There is no phase difference, right? And here, higher amplitude, here, here, here. And this line is actually joining the particles which are in the same phase. But whether these three particles are of same wave, no, they are actually of different waves here. Similarly here, this particular point, third line, dotted line I have shown. Here also, the line joining the particles which are having or possessing the same vibration or same phase is called what? Wavefront. Okay, so this is what? This is actually just basic I have shown. Look at here. So here what happens? Here ray of light travels in one direction, maybe consisting of not many rays will take. There it was geometry. Instead of showing like this, it was just a straight line we used to show. Correct? So here what we can say, so it's a line or surface, okay, joining all the particles which are actually having the same phase. Okay? Like this also. So line joining all the particles which are in same phase. Okay, this has shifted slightly. We'll redraw, no problem. So a ray traveling straight. One more. So line joining all the particles which are in same phase is called wavefront. Sometimes line we can say, or surface also we can say. Why surface? Because there are different types of wavefronts are there. Okay, so for example, imagine you are receiving light ray from a bulb which is very near to you. Very near to you means how it looks? Bulb, correct? Ray of light just spreading in all the direction, correct? Like this. So wave will be like this, right? Some of the waves I am showing here, okay? Like this. So it looks like, if I take only this much part, it looks like what? Ray of light spreading from one particular point. So all these things are actually in the same phase, correct? So it is spreading. It looks like what? A part of a sphere, correct? It looks like what? If you take all the wavefronts together, only this much part I have taken means, looks like this. So entire thing looks like what? A big sphere, correct? So that has got one particular name, that is called spherical wavefront. It's an example for spherical wavefront. From a point source, if light spreads, spherical wavefront. Imagine that a star is there at infinite distance, and from there light is coming means, do you think that if a object is there at infinity, from here whether spherical wavefront will come? Yes, of course. Spherical wavefront will come like this. Okay, but while spreading for infinite distance, what happens? They almost looks like what? Coming parallelly, correct? So when we receive light from a source from far away place, from infinite distance, if it's very near, bulb here and waves in all the directions. So this looks like what? Spherical wavefront. From infinite, what happens? They have traveled longer distance, almost they look like waves are parallel to each other. So this is called plane. Wavefront. Okay. So wavefront means what? Surface joining all the particles which are in the same phase. First type, spherical wavefront. Example, keep a light source or bulb very nearby, and the light which is received by that, okay, that is waves, they are spread in all 360 direction in a spherical manner. So we can say the wavefront, the phase of the particles at one particular point. If you take wavefront is, that wavefront is spherical wavefront. Suppose you keep, example I am taking, a faraway place, we are keeping one source, and from there light is received, means the spreading light almost looks like coming from a infinite position, right, or far away place. They almost looks like parallel to each other, so plane wavefront. Now let us go for a linear shaped object. That means, for example, tube light. Okay, so tube light, for example, if I take, if it glows, means in all the directions like this, 360-degree direction it goes, right? It looks like what? Cylindrical shape. Am I right? Tube light, light wave coming towards you, one going like this, one going like this, in all the 360 direction. So tube light will be in cylindrical shape. So wavefront which is coming out also, if you take at one particular instant or position, the wavefront also, line joining all the particles also will look like what? Cylindrical in shape. So linear shape source, best example you can say it is, discharge tube or tube light, sodium lamp, all those are best example. So cylindrical wavefront diagram I have shown you here almost. So this looks like what, so in this direction towards you it comes, in all the direction it goes. Okay, so this is cylindrical wavefront. Best example, tube shaped bulbs. Okay, that is best example we can give. That is tube light is there, right? Fine. So we'll show that in a neat diagram now. Okay, basics I think you understood here. What is the basic regarding what is phase, what is a wave, what is the phase difference, what is wavefront. Wavefront means it's a surface joining all the particles which are in same phase. Correct? So let us go for wavefront explanation now. So in the two, that means all the type of wavefronts I will show you right now. Okay. So first let me go for spherical wavefront. So there is one source. I'll just take light ray like this. According to ray optics concept, it is like this, right? Wave optics concept, how is it? Like this, correct? The light wave will go like this. So here, see? Like this, it goes. All are in phase, correct? So, if you just draw that in some other form, okay, that means I am just showing ray of light now. Source, ray of light goes like this. Yes. If you take a dotted line, okay, the surface joining the particles. So here, imagine higher amplitude it was. So here also higher amplitude, here also higher amplitude, correct? So here also high intensity, here also high intensity. So this brightness should be one and the same, right? So what happens? This we can say that primary wavefront. Wavefront means surface, line joining all the particles which are in same phase. But here it is actually having higher intensity, higher amplitude it is there. That is why it is actually given like this. So this is called wavefront. Okay. So similarly, imagine after next one comes, right? That time also there should be wavefront, right? So I will take one more image, like, okay, diagram here. So here on, I will take wavefront, and here on I will take. Like this. Okay. So what we can understand from this? This is actually spreading kind. That means it's a spherical wavefront. If you note down all the direction, means it looks like a sphere right now. Correct? So spherical wavefront. So in spherical wavefront, what we can say is, so According to Huygens, okay, according to Huygens principle,